So in this lesson, we're going to talk about finding the probability of independent and dependent events. So when we're talking about whether something is independent or dependent, it all depends on what you're trying to do or what's causing the problem to do. So for instance, an independent event is an event where the outcome of one does not affect the probability of another. A dependent event is the outcome of one event does affect the probability of another event. So those are two different types of events, independent and dependent. And so if we had, for instance, we look at our two definitions and we talk about calculating, we'd have the probability of A and B is going to equal basically our distributive property, probability of A times the probability of B. So that would be an independent. And then so this is an independent, we'll put this in I here. And then dependent would be the probability of A and B basically is the same thing, the probability of A times the probability of B. But B is calculated under a new condition. So we'll talk about, B is calculated like if we were to flip heads and tails. So what's the probability of getting a heads and a heads? So you would get the probability of flipping a heads, and then after you flip the heads, what's the probability of getting another heads? You would multiply those two out. So we'll kind of go through some examples and kind of talk about what that would look like. So let's take a look at example 1. We need to identify each set of events as independent or dependent. So let's say, for instance, we rolling a number dice or a cube, and rolling a 6 on one cube and then 4 on another cube. Would these be independent or dependent? Well, these are independent events because rolling a 6 with one cube and a 4 with another, they don't affect each other. So how you roll one isn't going to affect how you roll the other one. So for A would be our independent event. If we take a look at another example, we say we're drawing a red marble from a bag, putting it back in the bag, and then drawing a blue marble. Are these going to be independent or dependent? Well, our probability isn't going to change. If we draw a red marble out and we put it back in the bag, our probability doesn't change because we put it back in the bag. So this one would still be an independent event. Now, had we taken that marble out, we take a red marble out of the bag, so we draw it out and we keep it out of the bag, our probability of drawing a blue marble has now increased because we've taken that red marble out. That would be a dependent event. So one way of determining probabilities is we can use a tree diagram. So, for instance, if a coin is flipped twice, use a tree diagram showing all the possible outcomes and what is the probability of the coin landing on heads both times. So we have two different events here. We can have a heads or we can have a tails. These are our two possibilities here. So we flip the first one and we get a heads, okay, and then we flip it again, we get two different outcomes with this. So again, we can either get a heads or a tails. If we flip tails the first time, again, our probabilities are going to be heads or they're going to be tails. So we have 4 different outcomes that we can have. You can have a heads, which took the top path. We take a middle path here, we can have a heads or a tails. We can have a tails or a heads, or we can have a tails and a tails. So if we wanted to find the probability of the coin landing on heads both times, we have 4 different outcomes, but only one is going to be heads, so our probability would be 1/4. So let's take a look at another example. We need to find the probability of drawing. Johnny has 5 blue and 4 red marbles in a bag. So he has 5 blue and 4 red marbles in a bag. Find the probability of drawing a blue, keeping it, and then drawing a red marble. So what we're going to do is first we need to find out the chance of getting a blue marble first. Okay? So the chance of getting a blue marble, we have a total of 9 marbles, and where there's a chance of getting one is 5/9. So that's our first one. Now that we've kept it, we only have 8 marbles left. So it means we have only 4 chances of getting a red marble. So it would be, we have 8 marbles here. Now the chances of getting a red now are 4/8. So since we found that, remember we went back to our original problem. The probability of A and B equals the probability of A times the probability of B. So we're going to multiply these two together. So when we do that, we get 5 times 4 is 20 over 72. And then we can reduce that So if we were to reduce that, you can put 4 into both of those. So 4 would go into 25 times, 4 goes into 72 8 times. So the probability of drawing a blue marble, keeping it, and then getting a red marble would be 5/18. So we can also talk about something that's very similar to probability would be odds. So odds are another way of describing the likelihood of an event. So odds of an event is a ratio expressing the likelihood of an event. So we assume that all outcomes are equally likely and that there are unfavorable and unfavorable outcomes. So the odds for the event are always, would be M to N, or the odds against the event would be N to M. So it depends on how you're looking at it. So if we took, for example, and we say a bag contains 6 red marbles, 2 yellow marbles, and 1 blue marble. What are the odds of drawing a red marble? So we look at how many we have here. We have 6 red, we have 2 yellow, and we have 1 blue. So we're trying to find the odds of drawing a red marble. Well, we have 6 total red marbles, 6 red marbles, and the odds of drawing a red marble would be 6-3 because we only have 3 other marbles left. So the odds, we could reduce that down, would be 3 goes into 6 2 times, 3 goes into 3 1 time. 2-1 would be the odds of getting a red marble. So if we also looked at what are the odds against drawing a blue marble, so if we're looking at how to find the odds of not drawing a blue marble, we have 8 marbles that aren't blue. So again, if I took this and we just kind of erase this, the odds of not drawing a blue marble would be, since we have a total of 9 marbles, but 8 of which are blue, the odds are pretty good that we're not going to draw a blue marble. So the odds would be, we add the 6 and the 2 together to get 8-1. So it would be an 8-1 odd of not drawing a blue marble. So you're just taking the total number of outcomes you have and determining which is favorable or unfavorable.